Hi, this is going to be a video about the profiler and using it in Unity and how to figure out if your GPU or CPU bottlenecked and what is taking your milliseconds away from you, um, and how to use the profiler. Basically, it's really valuable, and you really should put in the few minutes to watch this video because it will make your life so much easier, and it will probably clear a lot of misunderstandings that you have. Anyways, first thing you need to know is profiling in the editor has a lot of overhead. If you build and tick development build and on a connect profiler, you can profile a build, and that will not have the overhead of the editor. The editor is on the CPU. Sorry, the overhead is on the CPU. The GPU will not have any overhead. So if you actually profile the GPU here, it will be almost exactly the same in a build. Alright, first thing is we run the game, obviously. I think everyone knows the stats window, like CPU main, render thread, this stuff here. It's the classic stuff. The draw calls, the triangles and all that. But yeah, so we go to analysis, we open the profiler, and this is the CPU. You can choose higher, by the way, you just choose some a frame here to profile, and you can choose hierarchy, which is this, or timeline, which is this. I prefer hierarchy, and that's what I'm gonna explain. So hierarchy. There's an editor loop that is the overhead, the visible overhead of the editor. You can ignore that. It will be like counted. Like your game is going to is doing this. It's taking 4.5 milliseconds to do the editor loop. There's nothing you can do about that. You have to build and profile the build if you want better data. But what we're gonna focus on is the player loop, which is taking 12 milliseconds. You can see here in time milliseconds. That's how much it's taking, and it's sorted by default. I think from highest to lowest. If you expand the player loop, you will see render pipeline manager do render loop internal. This is for HDRP, and URP might be different, but it should be around the same. Built-in is quite different though, but what you're gonna learn about the profiler is the same, but the information the profiler is gonna give you is gonna be different. And then there's VFX update, that's for VFX. There's script run behavior late update, that's for your scripts. Um, and also, I think for the HD additional light data, anything running on late update, I think. Script run behavior update, that is for your scripts running on updates. And yeah, basically a bunch of other stuff. But you can usually just focus on the highest, like milliseconds, the highest ones here. And this is the biggest one. This is for the graphics stuff. Do render pipeline manager, do render loop internal. This is HDRP rendering your scene, basically post processing, lighting, shadows, and all that. Objects, draw calls. If you expand it here, you will see color results cull. This is custom culling, and I think if you had occlusion culling, it would be here as well, but maybe not. Maybe there will be a different option here. And then there's volume update. That is your volumes in the scene, and a volume is ticked every single frame, I think. So they take up some performance. The more you have, the more work it's gonna be put into it. Water service, you can ignore that. It's just something in my project. And yeah, also you can see the garbage collection here. DC alloc. See the whole player loop, which is my game, is taking 1.2 kilobytes, which is quite a bit. But yeah, so render pipeline or render request is where the big stuff is. So you expand that, and then you will see render camera and render, and that's what your camera basically. So you expand that, and you will see execute render graph. That's your render graph. So stuff like shadows, gbuffer, all the passes and all that stuff. And you could see how much they're taking. How long they're taking to be done. So render shadow maps is taking 0.60 milliseconds. And all that stuff. gbuffer is taking 0.25 milliseconds. Prepare lights for GPU is basically It's a lot of stuff, I suppose, but it's basically culling your lights. You know, it's the more lights you have, the more work this is gonna do. I'm currently using a very alpha version of 2022, but by the time 2022.1 is released, this will be optimized by a lot. So yeah, the more lights you have, the more work this is gonna do. Basically, real time lights, I should say. And yeah, basically. So there's also render camera. I think any means initialization, but I'm not actually sure. But yeah, the more cameras you have, obviously, the more work that's going to be done. But this is the same camera; it's just initialization, I suppose. And yeah, and then we can unpause so the profiler works again, and then we can go open the GPU module. The GPU module, if it's active, it will add some overhead to the CPU. So like if I open the CPU now, it's probably going to do more work. But that's just the overhead of the GPU module being active. Anyways, if you just select now again, also the place you select with your mouse matters. So if I select CPU, CPU shows up. If I select here under the GPU shows up. So if we just select a frame, we will see this is the GPU now. The GPU, also you can see here, the CPU is taking 15 milliseconds, the GPU is taking 13 milliseconds. So right now I am CPU bottleneck. But if I actually made a build, I will be GPU bottleneck, because remember the CPU, if we go here, is taking 2.24 milliseconds in the editor loop, and also the player loop that is 12.50 milliseconds, 76 milliseconds, will be even lower on a build, like probably quite a bit lower. So although in the editor I am CPU bottlenecked, I'm actually GPU bottlenecked. So if we go to GPU here, we see that it's taking 13 milliseconds. And the GPU is much simpler. The profiler of the GPU is much simpler to just understand. You expand here, you keep expanding, because these are the big ones. You know, the rest are just not significant. You keep expanding, and then you have the render camera and render new game object. This is where the stuff happens. So you open the render camera, and execute render graph is taking 6.5 milliseconds. You open it, and there it is. Deferred lighting is taking a lot of time. G-buffer is taking a lot of time. Ambient occlusion is taking quite a bit. Post-processing, which shows all the stuff, you know, bloom and all that stuff. Exposure. Depth prepass, and contact shadows. And you can see exactly how much they're taking here. GPU milliseconds. So contact shadows are taking 0.26 milliseconds. And it just keeps going. Then you can remove it and go down to render new game object, expand that one as well, and see what's taking the milliseconds. I'm not even sure, but this is render forward error. Something went wrong, I suppose. Deferred lighting, render shadow maps, deferred depth previous, G buffer, all that stuff again. It's taking some work. I'm not quite sure what's the difference between these two, but obviously there's a difference. But yeah, basically, and this is what's taking the work in your GPUs. And from this, we can tell that in the editor, the bottleneck is the CPU right now, but the actual bottleneck is the GPU. Because remember, there is no overhead on the GPU. It will work. It will be exactly the same on a build, or like next to the same, basically. Like it's very similar. Also, the GPU GPU profiling does not work on DX12, I think. So if you're using DX12, profiling the GPU will not work. It will just not show anything. You have to use DX11. If you're using ray tracing, that obviously is a bummer, but yeah. In that case, you actually can use, I think, RenderDoc, which should work. And I could be wrong. It could be that DX12 does work with GPU profiling. So don't take my word for it. Try yourself. And maybe if it's not working now, maybe in a future version it will. But yeah, basically, and there's obviously other stuff like memory, and you can really see a lot more stuff. And if we go back to the CPU, you can even change the thread. This is the main thread. We can change it to the render thread. We can change it to the render thread and see what the render thread is taking. Like here, it's saying that the render thread is waiting for commands from the main thread. So the main thread is the I guess you can say is the bottleneck, because the render thread is waiting for the main thread, and you can actually see the same in if the GPU was the bottleneck. The main thread would like there would be something here saying waiting for state or something like that, or GPU, and that means the main thread is waiting for the GPU. It's done its work, but the GPU is still going. So yeah, it's really simple. There's not much to it. Once you understand how to use it, it's really helpful, and you no longer have to guess what your bottleneck is or what's taking your performance. And also, if you build using AL2CPP, which converts all your scripts and stuff, and the engine scripts, C# scripts, into C++, you would gain even more performance on the CPU side of things, which is nice. So if you can do that, or you should try it at least. And if your game runs stable, you should do that. But yeah, that's basically it. I hope you learn profiling.